Lesson 2, Deep Flight 1, Building Inequalities and Equations to Solve Problems. Getting started. Lemonade at the pool. The concession stand at a local swimming pool sells small and large glasses of freshly squeezed lemonade. This weekend, they made more than $250 selling glasses of lemonade. A large glass of lemonade sells for $4, and the total sales generated for selling small glasses of lemonade was $65. Number 1, write an inequality to represent the relationship between the amount they made and the number of large glasses they sold. So when we're thinking about this concession stand, they're going to take their profits from the large glasses of lemonade, add it to the profits for the small glasses of lemonade, and we know in our problem that that was more than $250. So we're going to use the greater than, more than $250. So now we need to ask ourselves, what do we know about the large glasses of lemonade? Well, we know that the large glasses of lemonade sell for $4. So that's going to be $4 each. Each glass of lemonade sells for $4 each. So for every large glass of lemonade sold, it's going to cost $4. Plus the small glasses of lemonade. What do we know about the small glass? We know that the total sales for the small glasses of lemonade was $65. So this is going to be our inequality. 4x represents the number of large glasses of lemonade. Four multiplied by the number of large glasses of lemonade plus the $65 from the small glasses of lemonade will be, or was, greater than $250. Number 2, solve the inequality. So we have our inequality. 4x plus 65 is greater than 250 that we're going to solve. We solve inequalities the exact same way that we solve equations. We're going to circle our variable term, draw a line at the inequality to separate the left and the right, and then first we're going to get rid of this constant. Right now this constant is plus, so we're going to do the inverse and subtract. What we do to the left, we have to do to the right, minus 65. It cancels because it made 0 pairs on the left, and we bring down the 4x. On the right side, we're going to subtract. And we get 185. Right here we have multiplication, so we're going to do the inverse and divide. A fraction line is a division sign. 4 divided by 4 cancels, and we're left with x. 185 divided by 4, you're going to have to divide that out. So once you have this divided out, you should have gotten 46 and 25 hundredths. So x has to be greater than 46 and 25 hundredths. Now we need to interpret the solution in terms of the problem. So if you remember back, x represented the number of large glasses of lemonade. So in order for them to have made greater than $250, they had to sell greater than 46 and 25 hundredths large glasses of lemonade. So can we sell, does it make sense to sell a quarter glass of lemonade? No. They either sell you a glass of lemonade or they don't. So it's either a whole glass or nothing. So in terms of this situation, the concession stand sold greater than 46 glasses of lemonade, which means they had to have sold 47, 48, 49, 50, and so on glasses of lemonade. So you might need to pause the video. That way you can write what was said. They sold 47 or more large glasses of lemonade. So if we put that on a number line, on number 3, our number line is completely blank. That means we can basically put our numbers wherever we want. So I could say, here's 0 on my number line, negatives are on the left, positives are on the right, and I'm going to find 47 because remember it's greater than 46 and 25 hundredths. So that would be 47, 48, 49, and so on. So here's 47. They sold 47 or more, greater than, so that's going to be 48, 49, 50, everything this way. So we're going to draw our line and shade it in to the right. And that's our getting started. Activity 2.1, unit rate of change. To explore one of the last unknown regions of our planet, companies are starting to produce single-person submersion deep-sea submarines like the Deep Flight 1. Suppose the submarine Deep Flight 1 is going to do a dive starting at sea level. Sea level is 0. We consider sea level to be 0, so they're starting at 0 and descending 480 feet every minute. To descend means to go down, descend down. And if we're starting at 0 and going down 480 feet every minute, that means this 480 is negative 480 feet per minute, every minute. Number 1 is asking us to identify the independent and dependent quantities and define variables for these. Then we'll write an equation. So when we're asked to find the independent and dependent, we need to ask ourselves, what depends on the other? Does their depth depend on the time that they are descending, or does the time that they're descending depend on their depth? The depth is going to depend on how long they are descending, which means their time is the independent. We're talking about their depth and their time. Their depth depends on how long they are descending. So that means that the dependent variable is going to be our depth, which we can use the letter D. And our time is independent, we can use the letter T. That equation would be, just like in science, your equation for distance. We have our distance equals, so our depth equals our negative 480 feet per minute of time. So looking at number 2, our table, we could have just jumped down here and filled in our table. So the quantities, our independent quantity was our time, and our dependent quantity was the depth. Units of measure, time is being measured in minutes, and our units of measure for the depth is measured in feet. The variables that we chose were T for time, or you could have used M for minutes, and D for depth, or you could have used F for feet. Using our equation, we're going to fill in our table. If the submarine was diving down for 0 minutes, 0 multiplied by negative 480 is 0. 1 multiplied by negative 480 would be negative 480. Continue multiplying each value by negative 480. Okay, so these are the values that should be in your table. If you don't have them, pause the video and fill them in. And let's turn the page. We're going to jump down here to the middle, to this vocabulary. The unit rate of change describes the amount that the dependent variable changes for every 1 unit that the independent variable changes. So, unit rate of change is basically what were you multiplying by. In this situation, it's that coefficient that we used to multiply with. So unit rate of change, you need to write, is the coefficient. Coefficient. So in this problem, what is the unit rate of change? In other words, what is the coefficient in our equation? It was negative 480 feet every minute. Right here. This is our unit rate of change. .480 feet every minute, unit rate of change. On number 6, we're just going to do A. How deep would the submarine be after 2.5 minutes? So our inequality, our equation rather, was negative 480 multiplied by the time will give us the depth. So that was our equation. We're going to take 2.5 and multiply it by negative 480. So negative 480 multiplied by 2.5 equals the depth. So let's do that multiplication. So after you have multiplied Don't forget to move your decimal because you have 1 decimal place in the problem and 1 decimal place needs to be in your solution. After 2.5 minutes, 2.5 minutes, the submarine will have gone to 1,200 feet. Do not forget your decimal. A negative times the positive is a negative. The submarine is going down. So now we're going to jump ahead to number 8, construct the graph. We're going to use the points on the previous page and this 1 point to make the graph just like we did, plotting the points, just like we did in lesson number 1, put it on a plane. So once you have plotted the points, this is roughly what it should look like. Just like in put it on a plane, our points are not going to be perfectly on intersections, but you are going to plot the points the same way. On the x-axis, go over 1. On the y-axis, or in our y direction, negative 480. And then start back at the origin. 2 minutes down negative 960 for each point.